When you look around, it's hard not to think about a pretty basic question. How are we going to feed everyone on this planet? I mean, it's a question that really brings in stuff from all over. Science, society, tiny little organisms in the dirt, all the way up to the way food moves around the world.
It's a question we get a lot, for sure.
Okay.
And that's why for this deep dive, we've really gone all in on a huge range of information. So we're talking about the global population and where it's headed, how we're dealing with the essential stuff like water and land. And then there's the elephant in the room, climate change, and how it's affecting everything, plus all the new and exciting technologies coming out in agriculture these days.
Exactly. And we're going to get into some of the complicated parts too, like food systems and how food actually goes from the farm to your plate and the whole tangled web of international trade, because so much of what we eat comes from somewhere else, right? And then there's the whole issue of food waste, which is just, well, staggering. And of course, we have to talk about health and good nutrition too. We'll even be looking at things like our values and the way we talk about food. All of this ties into the biggest challenge of all, making sure everyone has access to enough good food all the time.
Yeah, and what we really want to do with this deep dive is pull out the most important points from everything we've learned. We want to connect all the dots and give you a clear picture of the challenges ahead. We'll focus on global food security and all the possible ways to move forward.
Okay, let's start with population, which kind of sets the scene for everything else. The UN has some pretty interesting models, and their no-change scenario paints a pretty dramatic picture, doesn't it? They basically assume that birth rates and life expectancies stay the same, and, well, we're looking at something like 19.7 billion people on Earth by 2100.
That's right. We'd be adding another 12 billion people.
Right.
Think about the food, shelter, and everything else all those people would need. It's a lot to get your head around.
It is, but the thing is, that kind of extreme projection probably won't happen. I know it might seem strange, but as living standards improve and people aren't dying young as often, they actually tend to have fewer kids. And our sources have some pretty good examples of this playing out in real life.
Yeah, exactly. I mean, it seems counterintuitive, but the numbers back it up.
For instance, look at Mexico. Between 1960 and 2014, life expectancy went way up, like from 57 years to 77. And during the same time, the number of babies each woman had went down from 6.8 to just 2.2. That's a huge change in a pretty short amount of time. And a lot of that is because family planning programs were introduced.
We see the same thing happening in other countries that have moved up to middle-income status.
Good.
Like, take Myanmar. Between 1960 and 2014, their life expectancy went from 43 years to 66.
Right.
And their fertility rate also dropped drastically, from 6.1 kids per woman down to 2.2. Even in countries where incomes are still lower, like Mozambique, we're seeing this trend. Life expectancy has improved there, going from a really low 25 years up to 55.
Right.
But the drop in how many kids people are having has been slower. It went from 6.6 to 5.4. So you can see there's progress, but it's at a different pace.
Yeah, and these changes in how long people live and how many children they have are really important for understanding why that initial really high population projection probably won't actually happen. But it's not just these overall trends, right? There are always things that can pop up and throw these predictions off course.
Exactly. Like take China. They recently relaxed their one-child policy. I mean, that policy was in place for a long time. And now, think about this. China has a huge population. Right. So even if the average number of children per family goes up just a little bit, it could have a big impact on their overall population.
Yeah.
I mean, we're talking noticeable shifts in the coming decades, all because of this one policy change.
And on top of all of that, the way people are spread out across the world is changing too, right?
Oh, yeah. Big time. Our sources are projecting a massive increase in Africa's population. We're talking a huge amount of growth over this century. By the end of the century, it's predicted to be bigger than any other continent by far. Europe, on the other hand, is looking at a completely different situation. They're actually facing a shrinking population. Right now, they make up about 10% of the world's population, but by the end of the century, it's projected to be less than 6%.
Wow.
And you even see stuff like Italy's Fertility Day. It sounds kind of funny, but they were trying to get people to have more babies. And then there's Germany. They've had fertility rates below replacement levels since the 1970s. That basically means they're not having enough babies to keep their population from shrinking.
It really does create a kind of global divide, doesn't it? You have these slower growing, wealthier countries in places like Europe and North America where people are living longer and having smaller families. And then you have the faster growing, poorer countries, many in sub-Saharan Africa, that are already having a hard time feeding your people. It's a big challenge to think about on a global scale.
It is. And the big takeaway here is not just that the numbers are changing. It's that global demographics are being totally reshaped. That's going to put enormous pressure on resources, especially in the regions that are least equipped to handle it.
Yeah, and our sources have this hypothetical scenario that really makes you think. Imagine the U.S. having to double everything in just 25 years. Housing, food production, healthcare, schools, transportation, all of it. Could they handle it?
Probably not.
I mean, even a rich country like the U.S. would struggle, right?
Right.
Now, think about that same scenario in a country like Niger. Their population is actually projected to double in that same time frame. The challenges are just immense.
Totally. But there's a flip side to all this. When birth rates go down rapidly in a country, they might get what's called a demographic dividend. It's basically a window of opportunity. South Korea is a really good example.
Okay.
Their fertility rate dropped incredibly fast, from 6.2 kids per woman down to just 1.5.
Wow. And how long?
That all happened in just 25 years.
Really?
Yeah. And what this did was create a situation where a big chunk of the population was of working age, with fewer kids and elderly people to support. It's a huge advantage, economically speaking. South Korea was able to use this to boost their economy really effectively.
Right. So there's this kind of sweet spot where you have lots of people working and contributing, and that can really fuel economic growth like we saw in South Korea. Okay, let's talk about another big population trend. People moving from rural areas to cities. I mean, this has been going on for ages, right? Think about England's Industrial Revolution. But it's happening on a massive scale today, especially in places like China, where economies are growing so fast.
Yeah, for the first time ever, over half the world's people live in cities now. That's a big change.
It is.
And it's not slowing down.
So what are the pros and cons of all this urbanization?
Well, cities offer a lot of opportunities, right? Like there are more jobs, better pay, and usually better access to things like education and healthcare.
Right.
But when cities grow really fast, it creates challenges too. More congestion, higher risk of diseases spreading, more pollution. Plus, there's something called the urban heat island effect.
Yeah.
Cities can actually be quite a bit hotter than the surrounding countryside, like 2 degrees Celsius hotter. And that contributes to smog and other health problems, especially in big, densely packed cities.
And a lot of these cities are in places that are going to be hit hard by climate change, aren't they? Like coastal cities dealing with rising sea levels. We're already seeing more flooding in places like Miami. And when those big natural disasters hit, think about hurricanes, tsunamis, earthquakes. Megacities are so vulnerable. We saw that with the 2004 tsunami and Hurricane Katrina.
Right, absolutely. I mean, the sheer number of people packed into a small area, it just magnifies the impact of those disasters.
Okay, let's switch gears a bit and talk about another really important resource, water. Our sources talk about how we've tried to manage water over time because it can be unpredictable, right?
Right.
We build dams and reservoirs, and in the U.S., we've been doing that for a long time. Agencies like the Bureau of Reclamation, the Army Corps of Engineers, they've built over 90,000 dams.
Wow, 90,000.
Yeah. And some of them are huge, like the Colorado River system, which can hold something like 77 million acre-feet of water.
That's incredible.
It is. You know, at first, those dams were mostly about supplying water, but now there's a growing interest in using them for hydropower. Yeah.
Generating electricity from the water. Plus, as climate change makes water availability more uncertain, there's a renewed interest in just storing as much water as possible.
It makes sense. And when we're talking about water, it's important to remember there are different kinds, right? There's the obvious one, blue water, which is the water in rivers, lakes, and underground.
Right.
But then there's green water.
Yep.
That's the moisture that's in the soil that plants use to grow. And then there's gray water, which is treated wastewater. Not from sewage, but other sources.
Okay.
And it's actually really useful. It can be used for irrigation, to water crops.
Now, water is obviously crucial for growing food, right? I mean, it's essential for photosynthesis. It's how plants turn sunlight into energy.
It is.
And animals need water to drink. Plus, it's needed to grow the feed that those animals eat. But the crazy thing is, plants aren't very efficient at using water.
Yeah, most of the water they absorb just gets lost through transpiration.
Transpiration. That's when water vapor goes out from the leaves. So only a tiny bit of the water a plant takes up is actually used to build itself up. It's like they're constantly breathing out water vapor.
And that's why water-saving technology is so important.
Yeah, definitely. A typical plant might have a water use efficiency of around 0.00005 moles of carbon gained for every mole of water lost. It's kind of a mouthful. But it means that for every molecule of carbon a plant uses to grow, it can lose up to 20,000 water molecules.
So that brings us to the whole idea of a food product's water footprint, right?
Yeah,
You'd think that raising animals for food would use a ton of water because they need to drink, right?
right.
But get this, for a hamburger, 98% of the water used is actually for growing the cow's feed.
It's not for the cow to drink itself.
Really?
It's for the food.
That's crazy.
Yeah. It's
Yeah.
pretty amazing, isn't it? And we should also make a distinction between blue water footprint and green water footprint, especially for beef production. If cattle are mostly grazing on pasture, where it rains naturally, their blue water footprint is a lot smaller. That means they're using less water from rivers, lakes, and aquifers. But if they're raised on feed that comes from irrigated corn, that blue water footprint goes way up.
Okay.
So a bigger green water footprint, where they're relying on rainfall and natural soil moisture, is generally seen as more sustainable
Okay.
because that water is naturally replenished.
Right. And it's important to be clear about what we mean by drought and water scarcity, too.
Yeah, good point.
Drought is usually short term, right? Like
Yeah.
when rainfall is way below normal for a while.
Right.
But water scarcity is more long term.
Yeah, it's a chronic condition where there's just not enough water to meet demand. And it's a problem that's not going away anytime soon.
Right. And irrigation has been used for thousands of years to help crops get a steady supply of water. But the way we use groundwater, the water that's underground, is often not regulated as much as surface water.
Right.
And that can lead to problems, especially during droughts when people start pumping more water from those underground aquifers.
Yeah, and they can get depleted faster than they can recharge naturally.
Right. Like what happened in the U.S. Corn Belt in 2012.
Oh, yeah, there was a huge drought there.
Yeah, and they had to pump a lot more groundwater to keep those crops alive.
Yeah, and it's a problem in lots of places, especially as climates get more unpredictable.
But on a more positive note, our sources mention some really interesting things that are happening with water management.
Oh, yeah?
Like some cities are sending treated wastewater, that gray water we talked about, to farmers to use for irrigation.
That's great.
And that actually can increase the total amount of water in a river system because you're adding another source.
That's clever.
Yeah. Okay, let's talk about land now. And not just the land itself, but the soil. You know, the Dust Bowl in the 1930s was a big turning point in the U.S., wasn't it? It showed everyone how important soil health really is, and it led to the government getting a lot more involved in things like land management and soil conservation.
It definitely was a wake-up call. But our sources point out that we haven't always learned from our mistakes. Like during World War II, there was this push to plant more wheat, so they plowed up a lot of grasslands. And guess what happened?
The same thing, soil erosion.
Yeah, same thing. And then later on, in the Great Plains, they overused the Ogula Aquifer, which is this huge underground water source. They use it for irrigation, and that's a major problem now.
And it's not just about overuse, right? The cost of doing proper soil conservation, it can be really expensive.
Yeah, it can be. Our sources talk about Iowa, where they estimate it would cost over $1 billion every year for 50 years just to reduce nutrient and sediment loss by less than half. That's $1.2 billion every year for 50 years. It's a lot of money.
It is a lot of money. And you know, our relationship with the land has changed so much. Like 200 years ago, almost everyone in the U.S., like 98% of people work in agriculture.
Really?
Yeah, but today it's less than 2%.
That's a huge shift.
It is. And so many people are just disconnected from how their food is grown. But the pressure on our land is only getting bigger.
Yeah. And our sources share some interesting stories from farmers who are already feeling the effects of climate change. Like this tomato farmer in Indiana had to start planting in sandier soil because his fields were getting too waterlogged from all the rain. And in Colombia, farmers who grow tropical crops are having a hard time because the rainy and dry seasons are getting all messed up. It's making it really difficult for them to plan when to plant and harvest their crops.
And that leads us right into the whole climate change issue. Rising temperatures are a big problem for agriculture. When it gets hotter, plants develop faster, and that can mean less time for the greens to grow, which means lower yields.
Exactly. And it's not just about how much food we can grow.
Right.
Higher temperatures affect the way plants use carbon.
Okay.
They respire more, which means they breathe out more carbon dioxide at higher temperatures. And that happens faster than they can take in carbon dioxide through photosynthesis.
Right.
So the whole balance gets thrown off. Plus, all that extra carbon dioxide in the atmosphere, the stuff that's causing global warming, it can actually make some of our staple crops less nutritious.
Okay.
Like things like rice, wheat, barley, potatoes, soybeans. Studies have shown they can end up with less protein when there's more CO2.
And that's especially a problem in poorer countries, isn't it?
It is, because those crops are often the main source of protein for people.
Right.
Now, I know it's not all bad news.
Okay.
Climate change might have some good effects in some places, like
Right.
at higher latitudes, the growing season could get longer, which would be helpful for farmers.
Okay.
And there's something called the CO2 fertilization effect. Basically, more carbon dioxide in the air can sometimes make plants grow faster because their stomata, the tiny pores on their leaves, close up a bit, and that helps them save water.
Right.
But our sources say those benefits are probably only temporary. Overall, the bad stuff is going to outweigh the good stuff as climate change gets worse.
Right.
And the IPCC, the Intergovernmental Panel on Climate Change, they basically say that in the near term, like up to 2030, the effects of climate change on agriculture are kind of mixed. There will be winners and losers depending on where you are. But after that, after 2030, it's pretty much all downhill. Some studies are even predicting that harvests could drop by as much as 50% later this century.
Wow, that's a lot.
It is. But the good thing is that we humans can adapt. We can change when we plant, what we plant. We can even switch to completely different crops. Or we could just import food from other places where things are better.
But adapting isn't always easy, is it? I mean, in some countries, farmers get subsidized crop insurance. And that's supposed to help them if things go wrong, but it can actually make things worse.
Oh, how so?
Well, it can encourage them to take more risks because they know they'll be covered if there's a disaster.
Right. They might try to maximize their average yield, even if it means they're more vulnerable to extreme weather events.
Exactly. And the costs of adapting and even just having the knowledge and tools to adapt, it's not the same everywhere.
Yeah, no, it's not. Poorer countries are going to be hit the hardest by climate change.
Right.
But they have the least resources to invest in finding solutions.
And our sources point out that only about 3% of all the money spent on agricultural research worldwide goes to developing countries.
That's a tiny amount.
It is. And we also can't forget that technology can play a big part in helping us deal with these climate challenges.
Definitely. And I think we'll talk more about that later.
Yeah, definitely.
But it's important to remember that climate change and food security, it's not just about agriculture. It can lead to other problems too, like civil unrest in places where people are already struggling.
Right, and richer countries might have the option of just not farming in certain areas anymore, but that's not an option in many poorer countries where a huge part of the population depends on agriculture for their survival. And then there's the human cost of climate change.
Yeah.
I mean, heat waves are getting more intense and they're killing people.
Oh.
Our sources mention a heat wave in India that killed about 2,500 people.
That's tragic.
It is. And by 2030, they're predicting that extreme heat days will double. Like in the U.S., it could be almost 10 days a year. And in the tropics, where it's already hot, it's going to be even worse. And it's not just about human life. There's an economic cost, too. One estimate for China suggests that the economic cost of heat stress could be 200 times higher by the end of the century, like 3% of their whole GDP. It is. And think about this. Studies have shown that the best temperature for working in an office is about 22 degrees Celsius, 72 Fahrenheit.
Yeah.
But when it gets up to 35 Celsius, 95 Fahrenheit, productivity drops by 20%.
Yeah.
Now imagine you're a farmer in a developing country working outside all day in that heat.
And a lot of farmers don't have air-conditioned tractors or anything.
No, exactly. It makes it really hard to work, and it affects how much they can produce.
Absolutely. And let's not forget that agriculture itself is a big contributor to climate change.
Yeah, right. It accounts for almost half of all emissions from land use changes.
That's mostly from deforestation, right?
Exactly. And then about a quarter of agricultural emissions come from livestock and another quarter from soil management.
So what can we do about that?
Well, our sources suggest a few things. We need to minimize deforestation and plant more trees, manage existing forests better. Think about our diet choices, because what we eat affects how much livestock is raised, and that affects emissions. And we need to get smarter about how we use fertilizers, like when we apply them, how much we use, and what kind we use.
Makes sense. And some emissions from agriculture are pretty much unavoidable, like the methane that comes from rice paddies.
Right.
But there are things we can do to offset those emissions, like using cover crops. and reducing tillage,
Okay.
not plowing the soil as much.
Right.
Our sources talk about Brazil as an example of how government policies can make a big difference in deforestation. They really need to keep working on reducing it.
Yeah. And even though international climate agreements are complex and sometimes countries back out of them, like with the Kyoto Protocol and the Paris Agreement, there are a lot of other countries, states, cities, even companies that are still committed to reducing emissions.
Yeah, that's encouraging.
Okay, let's talk about the progress we've made in agriculture. We've had these agricultural revolutions, right? And technology has played a huge role in preventing the kind of widespread famines that people used to worry about.
Oh, yeah.
Yeah, like Thomas Malthus, he was really pessimistic about population growth and food supply.
Right.
But those agricultural advancements have really helped us keep up with the growing population.
Yeah, definitely. And we've had a couple of major revolutions in agriculture.
Yeah.
The first one was way back when people started settling down and farming in one place.
Okay.
That made food production more stable and reliable. Then we had the second revolution. It started in the 1800s, but really took off in the 20th century. It was all about science and technology,
Right.
like huge advances in plant science, chemistry, engineering, genetics.
Right.
We started using machines on farms, and agriculture became a lot more commercialized.
So what were some of the big breakthroughs?
Well, one really important one was figuring out how plants use nutrients. Scientists like Justus von Liebig and Carl Sprengel, they did a lot of work on that.
Yep.
And that led to the development of chemical fertilizers, which really boosted crop yields.
And they were using the law of the minimum, weren't they?
Yeah, the idea that a plant's growth is limited by whatever nutrient it's lagging the most.
Okay.
And then there were the advances in plant breeding.
Right.
We were able to create hybrid crops that were more resistant to diseases and had better nutritional content.
And a lot of that research was done at universities and government institutions.
Yeah.
It really set the stage for what we called the Green Revolution.
Yeah, the Green Revolution.
Yeah.
It started after World War II, and the goal was to increase food production, especially in Europe, where there were shortages after the war, and in Asia and North Africa, where populations were growing really fast. It was all about modernizing agriculture.
Right. And Europe was able to recover pretty quickly after the war because they already had a good research infrastructure and they were able to adopt new technologies quickly. But in other parts of the world, it was slower because they didn't have as much research capacity and they were still using a lot of traditional farming methods.
But the Green Revolution was really successful overall. There was a lot of international cooperation, sharing of technology, and development of new crop varieties that were adapted to local conditions. They also invested a lot in rural infrastructure, like irrigation.
And our sources mention Mexico as an example. Their wheat yields went up 4 times between 1940 and 1965.
Wow.
And the International Maize and Wheat Improvement Center, CIMYT, played a big role in that.
Yeah, they did a lot of great work. And the impact in Asia was really transformative. They developed these high-yielding rice varieties that helped prevent famines.
Right.
Like, the amount of rice produced in many Asian countries doubled in just 20 years after the food shortages of 1965.
That's incredible.
It is. But Africa didn't really benefit from the Green Revolution as much at first.
Yeah.
There were some challenges, like the crop varieties weren't well suited to African soils and rainfall patterns, and they had a wider variety of crops compared to places like Asia, where it was mostly rice and wheat.
Right.
Plus, they didn't have as much knowledge about plant breeding, and there were a lot of socioeconomic problems, like poor education, political instability, and bad infrastructure.
But they've made some progress in recent years, haven't they?
Yeah, they have.
Oh.
It's important to point out that these new agricultural technologies have also had some negative side effects,
Yeah.
like biodiversity loss because we're clearing more land for agriculture, and water pollution from fertilizers and pesticides.
And that's why there's been a growing interest in organic farming.
Yeah, definitely. People are concerned about those environmental impacts. But organic farming only makes up about 1% of global agricultural land.
Wow, really?
And it usually has lower yields, like 8 to 25% lower than conventional farming.
So it's not really a solution for feeding the whole world.
No, not on its own. If we all switched to organic, we'd need way more land for farming. Plus, organic food is more expensive.
Right.
And a lot of people can't afford it. So our sources argue that if we got rid of all modern agriculture and just did organic, we'd end up with food shortages and famines.
So what's the answer then?
Well, it's about finding more sustainable ways to farm. And technology can help a lot here.
Okay.
We're talking about things like apps and data analytics
Mm.
that can help farmers make better decisions about planting, irrigation, pest management,
Right.
and that can reduce the need for chemicals.
Okay.
And then there's genetically engineered crops, or GE crops. I know they're controversial, but they're already being used.
Like those beet crops that are resistant to insects,
Yeah,
so
exactly.
they don't need as much insecticide.
Exactly. And they're working on GE crops for all sorts of other things.
Art.
Fruits, oil seeds, root crops. Crops that can tolerate drought or cold better.
Right.
Even crops with more nutrients.
That's amazing.
And some researchers are even trying to figure out how to make photosynthesis more efficient.
Okay, that's really interesting. So let's move on to food systems now. It seems like a simple question.
Mhm.
What's for dinner tonight?
Yeah.
But it really gets at something incredibly complicated.
Oh, yeah.
Yeah, how food gets from the farm to our plates. It's a really complex system, isn't it?
It is. Our sources talk about all the decisions that are made along the way, from the farm to the processor to the retailer
Mm-hmm.
and finally to the consumer.
Right.
It's like a chain reaction. If you change one thing, it affects everything else.
And it's all connected, isn't it?
It is.
So can you break it down for us?
Sure. So conventional agriculture, the way it works now, it's all about efficiency.
Right.
Big farms, lots of machines, using chemicals to control pests and weeds, all that stuff.
Okay.
And it works. It produces a lot of food at a low cost.
Right.
But there are downsides.
Right.
Environmental impacts, animal welfare issues, all those unintended consequences we've been talking about.
Right. Right. So how does it work? Take us through the whole system.
Okay, so it starts with the inputs.
Yeah.
Things like fertilizers, seeds, equipment, all the stuff that farmers need.
Okay.
Then you have the farmers themselves, growing crops and raising livestock.
Right.
Then those raw products go to processors and handlers
Mm.
who get them ready for sale.
Okay.
And finally, they go to retailers like grocery stores where we buy them.
Right.
And that's how it gets to our plates.
Right. And traditionally, it's been mostly about those big commodity crops, right? Like corn, wheat, soybeans.
Yeah, exactly. They're pretty uniform, and they're traded in huge quantities.
Right.
But now, consumers are demanding more variety. They want organic stuff, meat raised in specific ways, all sorts of things.
Right.
And that requires more specialized production on the farms and more complicated systems to keep track of everything.
Right. And even though big grocery chains like Walmart and Kroger are still the main players, there are more options now, aren't there? Organic stores, farmers markets, and all sorts of things.
Yeah. And this idea of credence attributes is becoming really important.
Okay.
Those are things that consumers care about but can't really see or verify themselves.
Like how the food was produced.
Yeah, exactly.
Mhm.
Like, was it environmentally friendly? Were the animals treated well?
Right.
And even big companies like Walmart are starting to pay attention to this.
Really?
Yeah, they're trying to show consumers that they're selling sustainable products and that they're reducing food waste and losses.
Interesting. And we're seeing farmers adopting new technologies and practices to be more sustainable too, aren't we?
Definitely. They're using solar dehydrators, creating shorter supply chains so food doesn't have to travel as far,
Okay.
using cover crops to improve soil health, LED lighting in greenhouses, even experimenting with vertical farms.
So all that stuff costs money, doesn't it?